Welcome back. We've just finished our footstep system, and in this video, we're going to fix a little bit of an issue that we have with our running animation. Now, to show you the issue, I'm going to go into the character folder and enter shooter character BP, and I'm going to select the camera boom and lengthen the arm just so we can see the feet better. So let's put this at a value of, say, 400 for the target arm length of our camera boom. Now if I hit play, we can see the full body of the character. And remember, we still have our inventory bar not showing, so when we're finished with this, we can show that inventory bar again. Now for the issue at hand. Let's go ahead and run forward. Notice that the run forward animation looks just fine. Now let's go left, and we'll see our left strafing animation also looks fine. Now the issue is when we're blending between the forward animation and the left strafing animation by hitting W and A at the same time. Let's see how that looks. Notice the feet get tripped up on each other, and the reason is because we're blending the forward run with the left strafe. And that is not something that mixes very well. The reason is because when we're running forward, the right leg is on the right side of the left leg. But when we're strafing left, the right leg steps behind the left leg. So these are two contradicting things. And when we mix these two animations together, it doesn't quite look right. This is a common problem in running animations for games that have strafing like this. And a common fix to this is to rotate the hips and play the forward running animation when we're running at a 45-degree angle. We're going to implement that solution in this video. Let's go ahead and get started. Now I'm going to close all of these assets that we have open except for the shooter anim BP. I'm going to go back out to the anim graph, and I'm going to zoom in to the section that we've commented and called rotate root bone. What we're doing here is we're taking our cached aim offsets pose and we're blending poses by bool. If we're not in the air, we're going to rotate our root bone by a float called root yaw offset. Now root yaw offset is 0 when we're running because this only affects us when we're standing still. Remember, as we look around, we're moving according to our aim offset, and root yaw offset is keeping our root bone still. The result of this is cached into our cached rotated root bone node. So we're going to make some changes here. Now, since cached rotated root bone is used further down the line, I want to make some changes in between these two nodes. And to make things clean, I'm going to cache off this blend poses by bool, so drag off of this and new save cached pose, and I'm just going to call this one cached rotated root. And now we can perform our changes here, and whatever we do, we'll save that into cached rotated root bone, which will be used further down the line. So now how are we going to rotate our hips? So let's use cache pose cached aim offsets and rotate root bone. Now, I'm only interested in the yaw, so I don't need to use this pitch. Let's uncheck expose as pin. And I don't need this mesh to component, so I'm going to uncheck this pin as well, so we only have yaw. Now, we're rotating the hips in the direction of our movement. Now, if we look at our running blend space, we have this offset yaw. And the value we're passing into that is called movement offset yaw. So let's get that. And we're going to pass this in. So what does this look like if we go ahead and use this pose? Well, I'm going to take our cached rotated root bone and plug this in and see what happens. Let's hit play. Now if we run 45 degrees, then the root bone is rotating towards that direction. So even though we're looking forward, the rotational value between our aim direction and our movement is represented by the movement offset yaw. So we're effectively rotating our hips towards that direction. So let's put a comment around these nodes. And let's say rotate hips toward movement direction. Now we only want the hips to rotate. The upper half of the body should stay where it is. So we need to rotate the upper half of the body back. We can use transform modify bone. Now, if we plug in the rotate root bone into the component pose, we'll get a local to component transform node by default. And if we plug the result of this into cache rotated root bone, we get component to local. So it comes back out from component to local space. Now, if we select our transform modify bone node, we need to choose the bone to modify. And since we're rotating the root bone towards the direction of our movement, we want to rotate everything above the waist back by the same amount. Now let's look at our skeleton. And if we type spine and select spine 02, this is the bone just above spine 01. This is a good bone to rotate. So let's use this bone. So back here on the transform modify bone, for bone to modify, let's select spine 02. And we're going to transform the rotation. So we can leave the translation on ignore. And for rotation, we're going to add to existing and leave scale on ignore as well. Now, how much are we going to rotate this by? Well, we're going to get our movement offset yaw, but we're rotating back the other way. So we're going to multiply this by -1. So multiply with a float times float and multiply this by -1. And then we can simply drag off of this and make a rotator. So make rotator, and we're going to use the Z component, which is the yaw, and plug this into rotation. So now what happens if we use this? Let's go ahead and hit play and find out. So now our hips are rotating, but our torso is staying in the same location. Now we do see something funny, and that's when we run in a very extreme angle. See, it's turning at an unnatural angle, and that doesn't look right. But as long as we're turning in a direction that's relatively forward, this looks okay. So we need to limit this. So what I'm going to do first is cache this off. So off of our component to local, let's say cache and select new save cached pose. And let's call this rotated hips. And let's actually spell hips correctly. There we go. So we have rotated hips. And I'll give this a comment for these nodes here. So I'm going to move these over. And for this part here, I'm going to comment this and say rotate torso back to normal. That way we know what we're doing here. So now we have a rotated hips, and we only want to use rotated hips if our movement offset yaw is a particular value. So let's make ourselves some room here. I'm going to select everything below this, starting at fabric SMG and going down, and let's go ahead and make a little bit of room, and that way we can place these down here. And now I'm going to use the rotated hips cached pose. So just below here, I'm going to right click and say use rotated and use cache pose rotated hips. Now we only want to use rotated hips under certain conditions. Otherwise, we want to use the regular pose that we had before we did all these changes, and we called that rotated root. So let's get a rotated root cache pose as well. So I'm going to right click and type rotated root and use cache pose rotated root. And we're going to use a blend poses by bool. Now I'm going to use rotated hips for the true pose and rotated root for the false pose. And now we just need to know when we should use rotated hips versus rotated root. And let's comment rotated hips and say turn hips toward movement. And for rotated root, we're going to comment this and just say regular pose. Now I don't want to turn our hips toward movement under certain conditions. We don't want to do this when we're crouching. We don't want to do this when we're not running. And we don't want to do this for certain values of our movement offset yaw. So what I'd like to do is create a Boolean variable. Now, we know how to create Boolean variables in C++ and expose them to blueprints. But while we're doing animation work like this, it's usually faster to work in blueprints. So rather than show you the long process of creating variables in C++ and setting them there, I'm going to show you the streamlined process of doing this in blueprints in the event graph. So let's go to the event graph and let's add a new variable. This will be a Boolean, and we're going to call this should turn hips. Let's compile, and we're going to set should turn hips. Now when should this Boolean be true? Well, we're going to check the value of movement offset yaw. So let's get that. We're going to get movement offset yaw. And let's first think about when we're running forward. Let's get movement offset yaw and get its absolute value. So we're going to get an absolute node. And let's check to see if this absolute value is less than a particular amount. Remember, when we're running diagonally to the left, movement offset yaw is about -45. And when we're moving diagonally to the right, it's about +45. So if we get that absolute value and check to see if it's less than 45, then we know we should rotate the hips. Now we can give ourselves some leeway, however, and make this a little bit bigger, say 60 degrees, but we're going to tweak this and see how it feels. I'm going to put it at 60 for now. Now we also don't want to be crouching. So let's right click, type crouching, and we'll get the crouching boolean. We want crouching to be false when we're rotating, so let's go ahead and get a not boolean for crouching. We also want to make sure we're running, so we can get our accelerating boolean called is accelerating. This should also be true. Now we can combine all these into an and add a pin so we can have a third. And if all of these are true, then and returns true. And we can set should turn hips equal to this value. So let's connect this. And this will be set every frame. So now that we have should turn hips, let's compile and go back to the anim graph and use that here. We're going to get should turn hips and plug that in to blend poses by bool. Now let's see what happens when we cache this into our cache rotated root bone. Let's go ahead and hit play. Now if we run, we get our strafing animation when we go left, but if we run 45 degrees roughly, then we're rotating our hips that way. Now we still get our mixed up animation. That's because we still need to adjust our running blend space, but at least we have our hips rotating. And the hips are not rotating when we're moving about 90 degrees to the right or left. More specifically, that threshold is plus or minus 60 degrees, because back here in the event graph, we used a value of 60 here. So our next step is to go into our running blend space and make sure that we're using our jog forward animation if movement offset yaw is plus or minus 45 degrees, which is halfway between the middle and this next section here. That's because our number of grid divisions is 4, but if we set this to 8, then we now have a grid division in between, and we can set animation poses here. We want to set our jog forward animation all the way out to -45 and +45. So let's search for jog forward, and we'll drag jog forward into the -45 and to the +45. We also want jog forward circle right and jog forward circle left in these locations as well. So let's drag in jog forward circle right for our -45 degrees and for our +45 degrees, and jog forward circle left for -45 and +45 as well. So now if movement offset yaw is in between 45 degrees and -45 degrees, we still get our jog forward animation. It isn't until we go beyond 45 degrees that we start to blend into our strafing animations. So let's save this, and now we can go ahead and play test this out. So if we run 45 this way, we're still playing the run forward animation, only our hips are rotated. And if we jog to the left, the hips rotate back and we strafe. This is a much more natural looking way to move. We can strafe to the right as well, and if we start running diagonally, then we get the run forward animation. Now when transitioning, we can set the interpolation time so the hips don't jerk so fast. Let's go back to the running blend space, and for interpolation time, let's give this a value bigger than 0, say 0.2, and let's see how this looks. Now we can also take a look at our animation blueprint in our anim graph, and when we're blending poses by bool, this also determines whether or not we should start rotating our hips, and this has a blend time as well. Let's give this some values about 0.3 each. Now let's play test this. Now we're rotating the hips a little bit more slowly so it doesn't look like it's jerking. Okay, so we can finally give this its own comment. So I'm going to go ahead and highlight these, hit C, and say rotate hips based on movement direction. So this fixes the issue that we had with our mixed up feet when running forward and to the left and right diagonally. So this looks a great deal better, and this is a common solution taken in a lot of video games involving strafing. All right, I'll see you in the next video.